Computers have proven immensely effective as aids to clear thinking. Muddled and half-baked ideas have sometimes survived for centuries because luminaries have deluded themselves as much as their followers, or because lesser lights, fearing ridicule, couldn't summon up the nerve to admit that they didn't know what the master was talking about. A test as near foolproof as one could get on whether you understand something as well as you think is to express it as a computer program, and then see if the program does what it is supposed to. Computers are not sycophants, and won't make enthusiastic noises to ensure their promotion, or camouflage what they don't know. What you get is what you said.
It's been widely debated in history. What came first, the chicken or computer music? The answer is the chicken. So now that we know that, how did computer music languages start hatching? Jake, that doesn't make any... Computers back in the day were nothing like computers today. They were big, clunky, and immobile. They used vacuum tubes instead of integrated circuits, and magnetic core memory instead of solid-state static and dynamic semiconductor memory. Computers rarely worked in real time, like most of our DAWs today do. People would sit down and write programs, then wait for days for a full 3-minute song. The first computer to ever play music was the Sazerac by Trevor Pearcey in Sydney. The Sazerac played early 50s popular music melodies. Its first performance was Colonel Bogey March, but unfortunately there are no recordings of this event. Another computer that came later was a Ferranti Mark I computer in 1951, which was more commercially available. Its first performance played Baba, Black Sheep, and God Save the King. The first thing that even resembled a music computing program was Music N, written in 1957 by Max Matthews. This was the first digital audio synthesizer, in other words, the first program for generating digital audio waveforms through synthesis. Japan was also at the forefront of the computer music game. In 1962, two dudes called Sekine and Hayashi from Keio University were using the Tozbak, which was actually a business-related computing device. Sounds were imagined by the composer and noted graphically, then were passed on to the technical research team who converted information into digitally synthesized notes, using digital to analog converters. A huge breakthrough in the 70s was by John Chowning, who is said to be the father of FM synthesis. FM synthesis is an aspect of synthesis where the timbre of a waveform is altered by another frequency.
Besides FM synthesis with Max, there are endless of other possibilities with other languages. Some other languages that we're going to focus on are Nyquist, C-Sound, Max MSP, Impromptu, Chuck, and Super Collider. So what's the point of a computer music language? The basic idea of a computer music language is the process of giving a computer a series of commands and carrying out a specific musical function through written code. A person could tell a computer to carry out a task as simple as sending a bang, or even utilizing another patch within that patch. Most computer music languages are objective visual-based code, which means that the user doesn't have to know any serious coding knowledge before engaging with the language. Some differences in computer music languages would include Max versus MSP. Some information is handled differently in computers. For instance, in Max versus MSP, Max handles MIDI information while MSP is handling audio information. However, MIDI and audio together can carry out complex tasks such as sound synthesis, digital signal processing, sound design, sonic diffusion, acoustics, and psychoacoustics.
Computer music languages can vary very greatly from one to the next. While all of these languages deal with audio, they each do it in a different manner, which results in a different product for each program. Some computer languages are text-based. Programs like Chuck, C-Sound, Impromptu, and Nyquist run off of text that is typed onto the computer. These programs look more like your everyday computer language. The programmer writes in letters, words, or numbers that correspond to specific functions, such as the waveform, frequency, amplitude, duration, phase, and much more. These programs look very much different from object-oriented programs like Max MSP and Super Collider. Object-oriented or graphical programs have more of a visual aspect to them, unlike text-based programs, which run strictly on words, letters, and numbers. These programs use objects, each which is specified to a certain function to be carried out. These objects are usually tied to multiple aspects of a program. For example, one object can control the waveform frequency and phase of a certain sound. While the visual aspects of computer languages may separate the outer jelly, they do not necessarily separate the inner jelly of these programs. In case that made zero sense to you, languages can look different and accomplish similar things. Computer music languages are used for real-time audio synthesis as well as for composition. Programs like Impromptu, Chuck, and Max MSP are used in real-time synthesis of audio. These programs work with sound which can be coded on the spot and edited very easily even in the middle of a performance. These programs allow for a lot of variation. One performance of a composition may sound different to the next performance of that same composition. These programs allow for improvisation throughout the entire performance that can change a composition in ways that an orchestra or band cannot. Programs like Nyquist and C-Sound are used more for composition. They deal with the creation of sounds which will be used later on in a performance. These languages are not used so much on the fly, but rather are done beforehand. Using these languages, the programmer is able to create an entire orchestra of various sounds and instruments to be used in a composition.
Computer music languages since their creation have created a new style of music that allows composers and performers to make their computers work for them, allowing for a type of music that could never have existed with woodwind, brass, or orchestra instruments.
Computer music languages have allowed for infinitely varying compositions, as well as infinitely varying performances within the same composition. Performers such as Pamela Z use these languages all the time for composition as well as performance.
Computer music languages have not only changed the music world of classical music, all forms of music have been impacted by these computer languages through the creation of VSTs that are made through languages to be used with any digital audio workstation, allowing for much more diversity in the creation of any type of music out there today.